Hello, welcome back to the second part of this talk on working with content graphs. If you haven't yet seen the first part, I'd suggest looking through it before starting this. In summary though, in the first part I talked about how we might want to classify content using taxonomies, why separating content from classification makes good sense. I demonstrated the Content Graph Explorer application and began to talk about semantic triples. In this second part, I'm going to go through building and using content graphs, and that will involve talking a little bit about how we apply semantic triples ideas to our content, a little bit about graph databases, how we build a content graph, how we use Sparkle, and how we use a number of different approaches to visualizing graph data. Back in my content example, by classifying documents using a structured taxonomy, we've begun to collect up a bunch of semantic triples. We have content items, each of which are identified by URIs. We have taxonomy concepts, each of which are identified by URIs. And behind the scenes, we've defined an information model that specifies how content should interact with taxonomy concepts, and those are also expressed as URIs. And in this particular example, this has the title EAT holds at claimants, etc., etc. And we've defined that it's classified with the subject of race discrimination, amongst other things. And this classification creates a semantic triple. We've got the URIs of the subject and the object, and the information model determines the predicate is has concept. That's because we've chosen to treat concept links within the subject's concept scheme as being a has concept type relationship. In effect, this triple says this article is on the subject of race discrimination, and here is the triple that results. This is written in a format called Turtle, which is a common language for storing semantic triple data. Now, at this stage you may be wondering, what's the point of all of this? Okay, we have defined a collection of facts that link up content objects with taxonomy concepts, but so what? Where are these facts managed and what are the benefits? Well, I'm just briefly going to go back to a diagram I showed you earlier in order to answer the first question. We need to put all of these triples into a place where we can handle them, where we can process and manage and analyze them, and that's a triple store. For the purpose of today's talk, a triple store or a graph database is simply a place where we can manage a collection of triples. Now, graph databases are incredibly sophisticated information systems that go way beyond the scope of this talk today, and actually they go way beyond my understanding. So I'm not going to talk about a huge amount of detail, and I'm not going to talk about specific products, apart from mentioning that this example uses the free standalone version of GraphDB. There are many other graph database products in the marketplace, and you may indeed be using some of them already. In our example then, when the user clicks on that Save button, the application creates a triple based on the article's URI, the concept's URI, and the predicate that I've defined to link them, and that triple is written down into this triple store at the bottom. In a while I'll talk about Sparkle queries, but for now I'll just mention that in the Content Graph Explorer we use Sparkle update queries in order to write our triples into the graph database. So what do we get back? Well, this is a very small section from a graph database showing the URIs for 3 content items. Let's look at one of them. These 6 rows are all about the same piece of content, the same content URI. Next to that we have the predicates that link that particular content item off to other things, and now you can see there are 3 has concept URIs, 2 has legal term predicates, and 1 has region predicate, and they in turn link off to 6 pool party taxonomy concepts. So there are 6 triples that have this content item as the subject. And indeed, if we go and look back in the Content Explorer, you can see how that came about. We have a single URI for a piece of content, and we have that linked to 6 taxonomy concepts. Each of those concepts has a URI, and this one will use the has legal term predicate, this one has region, these ones has concept. Now, just as I showed with the case of John and Janet and their collection of triples, we can use this triple store to analyze information that we've accumulated about our content. And by extension, if we start to use that triple store to store other information from across the enterprise, then we start to know more and more about our knowledge domain. As an aside, this is what the CEO of a UK PLC recently said on this subject. Once you connect together all of our company's assets, can you imagine the possibilities? Here is a business leader who has a keen awareness of the value of linking up information across the entire enterprise and then making that linked up information available to the entire enterprise. And although he didn't say so in as many words, I'm pretty sure he wasn't just talking about refining their search engine. Most organizations never go beyond a faceted search engine, but semantic technologies like these have the potential to give us ways to manage our information spaces that go way beyond the search box, connecting up all of the company's information assets. Let's look again at the earlier slide with John and Janet and their likes and dislikes. The beauty of information stored in triples is that they open themselves up to deeper analysis. Triples don't just stand alone, because there may be many triples that feature John either as a subject, he likes curry and he likes beer, or as an object, Janet knows John. We can ask specific questions such as, what things does John like, as I showed earlier. We can apply the same thinking to our content knowledge graph. We can ask, what content items have this subject, employment tribunal, or what subjects is this content item about, and so on. But in addition to answering specific questions, a content graph also opens up the ability to explore a knowledge domain in a variety of visual ways. Let's look at the content item that we saw earlier. We can see a content-centric view of this content item, and that shows all of the concepts that we've used to classify it. We can also look at the triple store view that corresponds, and this makes it easy for query engines to go and look at the data and dice it and slice it. But we can also take a graphical view like this, and in a little while I'll show how we can use this kind of interface to actively navigate and explore a content graph. But how do we actually get this data out? How do we interrogate a content graph and get useful information out of it? Well, the semantic web comes with its own language for querying graph data called Sparkle. This is a Sparkle query. Don't worry about understanding this in detail, I'm just covering its main features for today. This query is a bit different from other things you might have seen if you know query languages like SQL, but the core of it should be recognizable. We're saying retrieve everything that matches a specified pattern. In a Sparkle query, the pattern will contain a subject, predicate, and object. That's what $S, $P, $O is doing here. Putting question marks in front of all three means you're not constraining or predefining any of them, so this is probably the most general query possible. Be prepared for a lot of results if you don't use a limit. Now here's a slightly more sophisticated query. Here I want to find all of the things linked to a particular content item. So I need to put the URI for the content item in the subject position. If I wanted to find only certain types of predicates, say has concept, then in place of $P I could put has concept. and in that case we've been constrained in our results to just the first 3 in that table below. So the results come back in a table of this sort, or if you're doing it programmatically, it could retrieve a JSON package. Now you can probably see already that by chaining these together we can start to explore. So we could query for all content items that have been classified by this concept, and then all concepts from those content items, etc., etc. So this is the key point. A concept can classify not just this content item, but other content items. This and the structure of triples enables us to explore by chaining queries together. So we can ask a question like, what is this content about? Well, it's about these things, but in this particular case it's about employment tribunals. So what other subjects, what other content items are also about employment tribunals? And what concepts are those content items classified with? And so on. So we can build out a network that we can use to navigate seamlessly, to explore serendipitously our information space. We could add in other things here. For example, suppose we were storing author names. We could say, please tell me the author for this content item. What other content items has she written? And that gives us scope for other types of exploration across this kind of information space. The key point is that the triple drives everything. Now we're actively working on developing usable interfaces for exploring content graphs like this, and in a future talk I'll demonstrate these. Now I've talked a bit about Sparkle, and that's about all I'm going to say on Sparkle. I can recommend a great book by Bob Ducharme, and there are plenty of tutorials on the web. I would recommend you go and look at Sparkle if you're going to work with content graphs. So what's next? Well, I hope that what I've been talking about so far has made it clear that through this use of content-centered knowledge graphs, we can start to design better ways to store and manage content, and far better exploratory environments in which to discover and navigate around the knowledge in our businesses. We don't have to rely simply on search engines. Making this happen is within the grasp of most organizations, I think, with a bit of structured thinking and design. But here are the kind of things that I think we need. Content managed in a CMS and identifiable using a permanent unique identifier, and that's a URI. We need well-designed information taxonomies. We need ways to link individual items of content with their concepts. We need a place to store that, not in the CMS. And I think that should be a triple store. And finally, we need new interfaces, new exploratory interfaces to hold things together and to enable us to explore seamlessly across information spaces. And what's next from our point of view? Well, the Content Graph Explorer that I've demonstrated here today is real, and over the coming months we'll be building that out to provide clients with the kind of classification, exploration and discovery interface capabilities that I've been talking about today. If this sounds like the sort of thing that you want to see happening in your business, then please get in touch. We'd love to help you in achieving that. Okay, that brings me to the end of this talk. I hope that this has provided you with a good insight into how you could capitalize on your content using semantic technologies and building your own content graphs. For now, thanks for your attention and goodbye.